Is that as we see this tipping point coming closer, and Dr. West will talk about both sides of the story here. One of the things that reminded me of this presentation is a movie that came out a few years ago by Al Gore called Inconvenient Truth, and there's a bunch of stories have been presented. There were some issues about people sort of stacking the data, so on and so forth. And what's great about this presentation is I think you'll hear the full story. But realize Earth and Atmospheric Science, this is one of the best groups that we have at Purdue University, and when you rank it among the best of the best, they're among the tops in the country, if not the world. And so to get someone of Dr. West's stature to come in here and talk to you from his perspective as it relates to public health is truly a coup for me anyways. And I'm really, really glad to have you here, Dr. West. So without further ado, an introduction to Dr. West, and applause, please.
Thank you. Can you hear me? Okay. Well, it's a pleasure for me to be here today. I didn't go as far as Ireland. I went just to southwest Florida, Fort Myers Beach. I spent an enjoyable 10 days there in basking in the sun in 85-degree weather. And some of you experienced the same thing, I'm sure, if you went down south and to Florida particularly. I'm going to be talking today about what's sometimes called global warming. Other people just call it climate change, not necessarily saying what the effects are actually going to be. And it's a situation that has come up probably since around 2000, when the first report was put out by the International Conference on Climate Change, and it was sponsored by the United Nations. And it had a bit of a controversy at that point, and Al Gore got involved in it, as you hear. But the general idea is that because of the increase in carbon dioxide in the atmosphere and methane, that the temperatures were going to rise very precipitously, and in fact cause a lot of changes to take place, a shift of the different climates, a change in rainfall, and in fact what some of them claim is to cause more and more diverse weather conditions. We certainly have experienced the diverse weather conditions this last winter because, in fact, we've had one of the most snowy, cold, miserable winters that all of you can remember as well as me, and I've been here at Purdue since the 1960s. So we're going to see what the two different issues are. The first one you'll see will be what has come out now of the I'm still catching my breath. The report that came from the National Science Foundation and the Royal Society of Britain, and it will show you what appears to be what the very challenging situation is as far as climate change. And then it will be followed by a bit of a discussion of that, taking into account that perhaps things aren't quite what the United Nations people have indicated. So we have the first report that came out by United Nations, the second report, the National Science Foundation, and this is material that has just become apparent now within this particular year. So I got to figure out how this thing works. So we begin with looking at what appears to be a really challenging situation. Since the 1850s, the temperature has been rising, and you see the variations throughout the year, but the temperature has been rising at a very significant steepness there. But in fact, if you look at the side view of this, those are in basically in tenths of a degree centigrade or Celsius. So that in fact we would see that perhaps what this shows that the temperature increase has been about 0.4 degrees Celsius over the last period since Industrial Revolution, and that's the concern, that starting about back in here when the Industrial Revolution occurred, that you have a very steep increase in the Earth's temperature. Then we look at this in the next point of view, and you can see that there are a number of different ways that we could show this. First, in the case of the Arctic ice thickness, then the temperature of the snow anomaly in the northern hemisphere, the ocean heating up as we proceed through here, and then finally global sea rise. The idea is that as the ice melts off of the Greenland ice sheet and off the northern part of the Arctic Ocean, that ice turns into water, and the water turns into oceans, and the sea level is going to rise. Now, that's one of the big concerns I've heard people say. We've got to worry about Miami and New York City because the sea level is going to rise 2 or 3 feet, and it's going to create a lot of problems in the process. Well, to begin with, sea levels haven't risen as much as would be predicted, but in fact, it's definitely going to be the case that sea level will rise as the temperature increases. So the average surface temperature, we can look at that and see what it was against as a normal as 0 degrees back in 1980. We can see that that's where we have basically half a degree. That's Kelvin, which is the same as Celsius in its size of the unit. So that in fact that just shows that you have a half a degree increase that's happened in the last 50 years or so. And then in the case of the sun's energy, the other idea is that the people who are opposed to the global warming claim that in fact it's been the variation in the solar energy that's caused the heating of the Earth. And I think they're trying to show in this situation that in fact it really hasn't changed that much, that the sun's energy has been relatively constant over this period of time of the Industrial Revolution, so that in fact the argument that the Earth is heating up because the sun is more intense is a questionable answer to come to. So what leads us to this is that the carbon dioxide content is increasing. That you can argue one way or the other, but it's clearly the case that the amount of CO2 in the atmosphere has increased significantly in the last period since Industrial Revolution came in. Now, where the controversy comes in is that people who are in favor of global warming say that carbon dioxide causes the temperature of the atmosphere to increase in a direct way. And we have not proven cause and effect. We know that the carbon dioxide is going up. Now, whether that means that the temperature is going to rise at some predictable rate is still left to be decided. And that's one of the arguments that's going to be made, is that just because the CO2 goes up, the temperatures are not going to go out of sight necessarily. And we'll see. But you can see the Arctic temperature has stayed pretty much the same, whereas the carbon dioxide has increased markedly. That's known. I'll back up. That's known as the hockey stick approach, the hockey stick effect, because if you look at that, it looks like you got a hockey stick, and then the foot of the hockey stick is coming down. So that is what is called the hockey stick, because in fact the increase in carbon dioxide has been so markedly over the last number of years. So that's the annual temperature change that's shown, and looking at a 10-year or 60-year average shows that on average the temperature has indeed increased. Now this is one of the perplexing things is that the ice sheet that covers the North Sea is dwindling. It's melting back on a significant amount. As you can see, the orange outline is what it was a number of years ago, and the white outline is what it is at the present time. This would be in the middle of the summer when it shrinks to its smallest level. So that in fact, this is another fact. If you start putting facts together, the facts is that the carbon dioxide has increased, and that the Arctic ice has decreased, and that the temperature is gone up to some degree. And so that's the things that we need to scrutinize more carefully. So this is a sea level variation. You can see, but that's measured in millimeters. So a millimeter, there's 10 millimeters to a centimeter, and 2.54 centimeters per inch. So that looks like it's a whole lot, but it's really basically just several centimeters in water level increases happened over that period of time. The other thing, one who argues with this whole situation can say that, in fact, the slope of that line is relatively constant from the 1880s, when in fact, which tends to predate the real industrial revolutionary situation. So that that's the second argument, is that the global warming is caused by human activities, and that gets another question mark, is what has been the effect of human of our own carbon dioxide generation and burning of coal and automobiles and those things, as far as the sea level rise or the temperature is concerned. But I think you could say that the steepness of that curve is the red portion is not a great deal steeper than what the rest of it was. So this is the CO2 concentration, and again, you see that we've gone from basically 355 parts per million carbon dioxide to 390 parts per million. And so that is a sizable increase from 355 to 390 over the period since 1990. And so there's a sizable increase in the concentration of carbon dioxide. Of course, we have methane. That's another one. Now, methane is actually more of a temperature driver than is carbon dioxide. And that's one of the arguments that we get into. People who are under the gun for carbon dioxide generation say, well, what can we do about people who are making methane? And what about the methane that's coming out of sanitary landfills and out of sewage treatment plants and out of animals, like perhaps the cows and steers generate more effect than some of the other things we talk about because of all the methane they generate. But at any rate, that shows you what the carbon dioxide concentration has done. And then there's a claim that the acidity in the ocean is decreasing. So you can see that you've gone from a pH of 4.11 to a pH of 8.11 to 8.08. That's only 0.4 of a pH unit, but it still is a downward trend, and that holds true both in Bermuda and in Hawaii. That's shown there. So it would appear to be a worldwide situation in which the pH is of the ocean, the acidity, it's becoming more acid. It's still on the basic side. A pH of 7 is neutral, but you can see that you have a downward trend there. Now, this is the sad story scenario that we're talking about. If you looked at 2100, by the predictions of the sort of the worst case scenario, I think, you can see that the temperature of the world is going to increase by a significant amount from the yellow level back there of say 2 degrees from a basis of 2 to go up to almost 10. And so we got an 8-degree increase in Celsius over the next 100 years. That is that is the estimate of of all the different different calculations that are made, which are based on a lot of estimates that we'll soon find out. And one would claim that the argument people claim that this is too severe, that is not likely to be the situation that develops. Right. appear to be going the wrong way there. So we see that those are the different scenarios that you can see of different plots that people have made, different calculations, and that you showed the extreme case of the atmospheric carbon dioxide going up very significantly, and then you have some other. So these would be different programs that people have generated and show a range of what the situation would be, whereas the brown down here would be if we did drastic effects to control carbon dioxide generation, we would have a sort of a constant situation. But in fact, the worst case situation looks like this, in which you would go from 480, where we are now, up to 1800 in the next 100 years. This is what causes the whole effect. This causes the greenhouse effect, that the solar radiation comes in. Carbon dioxide and methane change the way in which the heat is expelled out into space, and more of it is held internally in the atmosphere, and consequently the atmosphere warms up because of the fact that it has these gases that are accumulating at a higher and higher level. And so that's the basis for the whole argument there. And then this is the other generation that you can see, that what we have, since we've gone, again, this kind of repeated the same information, that we started at 315 parts per million back here in 1960, and that anticipated that in 2015 we might get as high as 400. And so a very sizable increase in carbon dioxide content as some models look at this particular case situation. And then finally, this again illustrates what I call the hockey stick. See, you think of that as a hockey stick, and this is the foot of the hockey stick down here, and that's the increase that's happened in carbon dioxide parts per million from about 275 here, you see, up to a level of 350. So a very sizable increase in the concentration of carbon dioxide in the atmosphere. Now, again, the thing that we really don't know for sure is what is the relationship between the increase in carbon dioxide and the increase in temperature. The proponents of global warming would say that there's a very direct relationship because carbon dioxide holds the heat in, whereas we don't actually know all the details of this, in fact, whether the carbon dioxide has that direct effect or not. And so if we look at the decade averages, you can see that as we go by decade, the temperatures are increasing from one 10-year period to another. Whereas in this period back here in the 1950s, it seemed to have been relatively constant, and then we've jumped up and anticipating it getting up here quite high after we go after 2000. And so this is the worst case scenario shown here, that if we are careless and business as usual without trying to control the carbon dioxide, this model claims that we can go up, it can increase by something like 4 degrees Celsius, which would have a major effect on the climate of the world if that were the case, because we'd have droughts in some areas, we'd change the weather pattern, there'd be rainfall elsewhere, so it's going to be a very significant warming trend of 4 degrees Celsius. Whereas the best case relationship is down in here, which is pretty much status quo, but in fact it's going to take very dramatic control over our economy and our other aspects to be able to come close to staying in place approximately what we are at the present time. Now, what I've just told you is the story that we hear from the National Science Foundation. This is a report that just came out just this last February. So it's an up-to-date report of what the National Science Foundation and the British Royal Society would say is the relationship for global warming. And prior to that, the United Nations report that came out in about 2000 had a similar outcome, that the carbon dioxide would continue to increase, temperature would increase, and we'd have a very dramatic effect taking place. Now, what I'm going to do is tell you this is the second part of the story, page 2, if you like, and these are individuals who are not in tune with the National Science Foundation group and have looked at the data and come up with different interpretations of that. And so this is the second part, and you'll see a different idea in coming up in this respect. Now, these are responsible individuals. They're all atmospheric science people, and they also represent a worldwide community. But in fact, they have interpreted the data in what they think is a more a positive or appropriate way. And I don't know how much you're going to be able to see this, because these are things right out of the report. So I'll just read some of them. The atmospheric carbon dioxide is a mild greenhouse gas that exists and diminishing. Doubling the concentration of CO2 from its pre-industrial, in the absence of other things, would likely only cause, a change of 0.3 to 1.1 degrees C. So their claim is that the temperature increase relative to the carbon dioxide increase is not going to be as extreme as the National Science Foundation report said. A few tenths of a degree, should it occur, would not represent a climate crisis. Models published by the IPCC, that's the international group, reports since 1990 suggest a doubling CO2 would cause 6 degrees C by 2100. Instead, global warming ceased to increase, and is not up to that significant level. Although a future warming of 2 degrees would cause geographically varied economic response, no evidence exists that those changes would not be net harmful to the global environment or to human beings. And the current 400 parts per million we live in is a CO2-starved world. Atmosphere levels 15 times that great occurred during the Cambrian about 550 million years ago without known effects. That's why a geologist like myself has some question with the effects of global warming, because I know on the basis of geologic history that we've had glaciers we had 4 major glaciers within the last million years, one of which that covered most of Indiana. We've had glaciers that date back at the Cambrian time, which is over 500 million years ago. And we've had periods of glaciation that have occurred on a somewhat regular basis under the geologic time scale. So that the changes, the variation in temperature and of climate are not unknown to the Earth. So if we don't have to call on human activity to see that changes do occur in the situation of the Earth. No close correlation between temperature variation and human emissions. Have the parallelism of temperature and it could be due to chance and not necessarily indicate causation. So what they're saying is there's no necessary reason why the carbon dioxide going up and temperature increase being related to each other, because in fact they are independent situations, and there's a lot of reactions that take place to give rise to that. The cause of global warming remain uncertain, but significant correlation exists between climate patterning and multi-scale variation in solar activity. Forward projections of imply the next few decades may be marked by global cooling rather than warming. I can recall that it hasn't been too many years ago that people were concerned about global cooling that we were going to moving into another ice age. In fact, we've had, if you look back in the recent past, we've had some very bad winters. The winter of 1880 was really a major killer of animals in the western United States because it was so severe, and we've had some very major temperature variations within the last several hundred years, and so some of these things are not unique. Okay, so this is what these people claim that that the opposition has stated before. The doubling of the carbon dioxide would cause a temperature increase of 6 degrees. They differ with that. They say that number should be maybe only 1 degree. Human-related emissions cause atmospheric warming of 0.3 over the past 15 years. Inherent hotspots should have appeared in the troposphere, and both pieces should have warmed fast. Both poles should have warmed faster. Well, it turns out that the South Pole is not warming; only the North Pole is. So it turns out that the warming of the 12th century cannot be explained by natural variation. The 20th century warm period was greater magnitude, increase in the atmospheric, and then so what we're saying is that it's circumstantial evidence. So without going into all this detail, the second report disagrees with the conclusions of the first. And so here's some more information. The doubling from CO2 from 280 to 560 would likely produce a temperature increase of 3.7, which is about 1 degree C. So I guess the idea is that the amount of increase of temperature is not what they had predicted. They say that the warming trend would be about 3 to 6 degrees C, whereas empirical data indicate that it's between 0.3 and 1.0. So in other words, they haven't lived up to predictions that were made back in 2000. They've based some of this on ice cores that were taken out of the glaciers on the South Pole, and look at the carbon dioxide content through the history of that, and then so they talk about therefore CO2 cannot be a primary forcing agent. Atmospheric methane for the last 2 decades fall well below those projected by the IPCC. The melting of permafrost or submarine gas hydrates is not likely to emit dangerous amounts of methane. That's one of the catastrophic effects that they say could happen with global warming, because if we melt the tundra, say in northern Alaska, along the Arctic coastal plain, then all those organics start to decompose, and they give up carbon dioxide, and it would cause a colossal temperature increase because of the additional carbon dioxide. Well, these people disagree with that being a possibility. They say that that's not going to happen, and so we can discount that. I don't know. And they talk about atmospheric vapor and et cetera. So let's look at this figure here. And these are going to be available to you. I think these are available, aren't they? So you can look at those and scrutinize them to your heart's content. But you can see that this is what the second report has concluded, and relative to what had been previously stated, that the increase in temperature has been about 0.5 degrees C. And the ocean surface temperature and the atmosphere by satellites and these other measurements has not been increased. So from what they are concluding is that the increase in temperature is considerably less than what the predictions were made by the previous report. And then they go on to talk about the problems with climatic modeling. And it's just, you can read this for yourself, but what you find is that modelers have to make certain assumptions. At least three. In fact, temperatures is slightly cooling over this period of 15 years. They project the ocean warming at least 2 degrees C, and there's been no ocean warming, they claim. Climate models project the appearance of an upper atmosphere hotspot. They didn't find one. The climate models project 20th century warming should have occurred toward both poles. In fact, only warming has happened at the North Pole. Climate models assume a climate sensitivity of 0.3 degrees C for doubly great. See, this is the assumption here of relationship between temperature rise and carbon dioxide accumulation. Meteor observation consistent with a sensitivity of 0.1 degrees C instead of 3. Climate models underestimate surface evaporation caused by increased temperature. Climate models represent aerosol-induced changes inadequately, despite studies that show aerosols can cause differences in surface effects. The models are inherent properties that make dynamic prediction impossible. Limitations on the power restrict climate models for resolving the processing. And so you can just look at the way, but it's clear from this that we have two different scientific communities looking at the same information, and some of them coming up with a much more conservative or less catastrophic effect from what we have, let's see, is happening. So I'm going to pause here for a minute. I know that that you have some other activities coming up in quarter after, is it? So let me try to get some comments from you. As you look at this, which one of these arguments do you find more acceptable? The one that has been proposed by the United Nations report, and then secondly the National Science Foundation British report that has come out just recently, showing what the relationship predictions are. Who wants to help discuss this with me? I see somebody in a red jacket. I've been thinking about IU recently. What's your name? Yeah, Jordan. What's your idea of this, Jordan? What do you conclude from this? Anybody who wants to reinforce the idea of the first argument that things are much more drastic and a bigger calamity are going to occur than the second report? Anybody who's a strong proponent of the first information that's right, which is really more of the falling on the side of the greater environmental concern? Who would want to speak to that? Any ideas? How about somebody here in the front row? Yes, you. Yeah, would you? You're not? You're for the second? Yeah. What my idea is that we don't want to shoot ourselves in the foot on this. And as many people have argued, to be wrong on the side of being too unconcerned or too conservative may cause dramatic changes to the Earth that we won't be able to reverse. So that we don't really want to treat it casually or ignore it or say that this is just not something that we should have an interest in. But on the other hand, do we have to go to the extreme case of adjusting all of our economic concerns for this? Do we have to give up mining of coal, and which produces 75% of the energy in the state of Indiana and is a major employer in our economy? To what extent do we need to go to adjust to the concerns for the climate change, the things that we see are happening, the carbon dioxide increase and the methane increase and the other things that seem to be taking the case. We don't want to ignore it, but I don't, in my view, it's not worth sacrificing everything that we have invested in our economy just in order to get it taken care of. And so that's one of the views that we might have. So, and in fact, I'm encouraged by the amount of money that the National Science Foundation is spending on atmospheric science studies. In my own department, my department is the Earth, Atmospheric, and Planetary Science. So atmosphere is very important, and a lot of our faculty are doing research on various aspects of the atmosphere related to global warming and paleoclimates. We're trying to look back into the past and see what the climate was previously to try to predict what it would be at the current time. And we know, as I've said before, that we've had very cold periods in the past. We also know that during the time when coals were formed in Indiana, it's called the Pennsylvanian period, the temperatures were very high and the trees were very prolific, and there must have been an enormous amount of carbon dioxide in the air, much more than what we have today. And so, did it cause any permanent aspects to the changing of the Earth? Would not appear that it did. And in fact, that the Earth can, and certainly in the early history of the Earth, when volcanic eruptions were very, very common, because when we first started off and the Earth was molten and just cooling off and giving off huge amounts of volcanic activity, there had to be a lot more carbon dioxide in the air at that time. And so it had to have an effect on the temperature, and somehow the Earth persisted through that, and when it was not a catastrophic thing. Of course, humans weren't on Earth at that time. They had not evolved at that point back in the Cambrian period. We've only had humans around several million years now. So and in fact, we have this controversial situation of not ignoring it, but not going to the extreme level that maybe Al Gore or some other people would suggest that we need to do to cut back on that give up our automobiles and walk more, just because of the fact that we don't want the carbon dioxide to go into the air. Yes. That the business of having more snow. On the other hand, even the first report people have said that the variation we've seen this year is well within the natural variation that we have within the climate of the past. So those people who argue that this bad weather or warm weather are so extreme because of climate change are really missing the boat, because we know that climate naturally varies a significant amount. And I can remember years ago when we had the last blizzard of Indiana, was back in the 80s. And in fact, that was very, very cold at that time, and we thought, there's a new ice age coming. The thing is that there are many aspects of this whole thing, like you say, the amount of moisture in the air, the effects of other elements, as well as the carbon dioxide. What is the reaction between temperature and CO2? It's not a direct one-to-one relationship, because the atmosphere can adjust to it and somehow take on more carbon dioxide and maybe not raise its temperature very much. And so there are a lot of unknown situations. So I think the initial people, certainly back the United Nations report, jumped to a lot of conclusions that Al Gore actually championed and made the best of, and in fact invested in energy relationships and became a very rich individual in the process, and still flies around in his jet airplane that he owns himself. But in fact, I think, but that's one of it. Now the other thing is that there's always argument within the scientific community of what information you exclude and what information you include in your studies. And there was a claim that the United Nations people had omitted some of the coldest data that they had that occurred back in the 1880s. And so that's where some of the controversy has come from. Unfortunately, this has sort of become politicized and almost to the point that we get the idea that conservative people on the conservative end of the spectrum don't want to accept global warming. And people who are on the more, let's say, liberal side or the other opposite side are more willing to adjust and accept it and just think of it lockstep of what has been proposed in some of these different United Nations reports that we have. And so that's the unfortunate thing that I see, is that there's a lot of politics has been built into this business of global warming, whereas it's really more of a scientific thing that needs to be ironed out with a reasonable approach and with proper government funding. Another question, yes. That's true. The things are happening more in the northern hemisphere, but the northern hemisphere and the southern hemisphere are very different. You just look at the amount of solid land that you have in the northern hemisphere is much greater than it is in the southern hemisphere. And the circulation of the oceans is quite different too. The Arctic current, the one that they've been talking about in this missing 777 airplane that kind of circulates around Antarctica between there and Australia and very severe seas, is different than what we have in North America. So, and plus the fact, not only that's where the land is, that's where the people are, and people are generating a lot of heat. I mean, we are exothermic individuals, and so we do give off a sizable amount of heat per person, and that also relates to the effects of the temperature changes. So that's a significant point as well. I think we're back in business again. Let's go back and look at some of the early ones that we saw. Get back to the start here. I think this is one that is of interest to me, is that the rise in sea level. We certainly have not seen the amount of sea level rise that would be predicted by some people with global warming. If we get maybe 6 degrees Celsius warming, it would have a major effect on the melting of the ice caps, and so that you would get a very sudden major increase in sea level. And so, like I say, those are in millimeters, and so it's gone from about 100 to maybe 175 millimeters, which would be 10 centimeters, if I'm doing that right. And so, not the significant rise that had been predicted by a number of the models. And so that's one of the things I think we tend to do that, is that and we do that with extreme weather like situations. People will predict what the possibilities are for, like, for example, we could have gotten several inches of snow today by listening to some of the weather forecasters, when in fact all we got was a very small blanket of snow, and we tend to catch on to the extreme side of the variation and take that into account, where in fact it's more likely that it would be either some average or perhaps even below average as far as what's going to actually happen. So that in fact we do tend to get changes of that sort, and you can see that the average annual temperature does shown to increase since in the 1850s. You see there where it was, so that shows about an increase of 0.6 degrees Celsius, which is considerably less than what some of the predictive models would show us was the case. Where's my... And that's the carbon dioxide effect, and you can see how it has been predicted to increase at that same rate that we see at that time there. And the hockey stick, which I keep coming back to, is the one that was discovered back in the 2000 era, when in fact they started measuring the concentration of carbon dioxide, and then went back. And the portion that's shown here is based on taking ice cores into the Antarctic ice cap and figuring out and using oxygen 18-16 ratios to determine what the age of the material is, and then look at the carbon dioxide that's included in the dissolved gases to show what in fact was the CO2 level in the past. And the argument of the people who don't agree with some of this data is that these numbers are not exact because they're the questionable techniques that are involved and in general air bars involved may be such that they're not obviously correct in that respect. But we do see that this is the change that's occurring, and that's due to the Industrial Revolution, most likely to some effect. What in fact is the human contribution to that is the other part of the controversy. But I don't know if we have that, do I? Okay. Oh, right. I'm not successful in making this thing work. We have an Antarctic temperature, and that would not really seem to make a very strong argument that the variation that we have had peaks of this extent. Of course, this is 200,000 years ago. But you see, that's the sort of thing that I've talked about from a geological point of view. We've had very extreme temperatures on Earth in the past, and so this is not really an exception to necessarily that what we have at the present time. So that's the Antarctic temperature. And again, there's the current amount of carbon dioxide up here, 400 parts per million. Now, the other report would say, the controversial report would say that, in fact, the sun's energy has been the primary driving force for the temperature of the Earth, and yet these measurements suggest that it really hasn't, other than around 2000, it looks like it kicked in some extra energy. Now, whether there's a delay in what the energy input is to what the climatic conditions that occur are something else that would need to be discussed. But you see that the surface temperatures, as shown here, have just about a half a degree, 0.4 of a degree change that has occurred in the last 30 years or so. So anyone else have a question you'd like to ask? I see we have a few minutes left of the hour here. I'm not generally used to giving lectures that last an hour and 15 minutes like ours is today. I'm more keyed into the 50-minute discussion period, and that's what I kind of prepared this for. Do you have any suggestions how we proceed?